in this video I will be showing how to draw radiation pattern like E-plane radiation pattern as well as H-plane pattern using a tool generally used called originpro. So I'm using latest version 2020. It will be available for individual which have college email ID or something, organization email ID. You will be getting 6 months free usage for originpro. You can download it from the official website itself. So here let me show you that this is a sample bio inspired antenna. So it's like a maple leaf structure. So this is a basic antenna. So I just simulated it. So you can see the S11 value. So here the S11 value is here. So I'm getting a bandwidth of nearly 3 GHz, and the resonation point we will look at below minus 10 dB. So the resonation point I'm exactly getting at a point of 5.8 GHz around here, 5.8 GHz. So now I'm going to see the radiation pattern. So in order to see the radiation pattern, you can go to far field here in the last one, far field. So click on that, then you can see that the exact frequency I used as f is equal to 5.8 because that's what my resonation frequency. And if you click on that far field, f is equal to 5.8. so you can see the radiation pattern in 3D view, 2D view, Cartesian system and polar chart. So basically we will be drawing polar chart, right? So yeah, so now you can see the radiation pattern here. So it is phi is equal to 90 degree. So we have two settings, like phi is equal to 0 degree, then the radiation pattern is H plane, and for phi is equal to 90 degree, then the radiation pattern is E plane. So you can set accordingly. For example, like if you click on far field plot, then go to here in this particular area. So the step says you keep it as 1, and the cut angle, so the cut angle defines the value for the phi. Then if the phi is equal to 90 degree, currently the radiation pattern is for E plane, and if you set this particular value 90 as 0, so let me put it as 0 and press enter. Now it will show you the radiation pattern for H plane, that is equal to phi is equal to 0, and you need to select this particular option as gain only because okay. So this is the percent. So let me use E plane radiation pattern, that is phi is equal to 90. Okay, so this is the diagram, and now I'm going to tell you how to draw this, because once you go for a journal publication we need a standardized diagram instead of simply a screenshot. So right, so in order to do that, just create a tree folder under one dimensional results. So click on 1D results and just right button and click new tree folder. So a new folder will be created, and I'm going to give any name. I just give a name like draw. Okay, so now selecting the far field. Okay, then right button, copy. Okay, and go to the draw folder, the newly created draw folder, then Control V, paste it there. Now you can see that far field f is equal to 5.8, that particular file is created. Now you need to export this to text to file. Now in order to do that, so go to post processing phase. Okay, and by selecting this far field is equal to f is equal to 5.8 and go to post processing phase, then click on import for export and choose ASCII plot data ASCII format. So click on that, then it will ask you to save. Then you just scroll any one particular folder. I'm choosing pictures, and I'm giving the file name as E-plane. Okay, RP, in a sense radiation pattern. Okay, E-plane RP radiation pattern. Okay, fine. So save it. So this is the initial step, using what you generated the ASCII data for that particular E-plane radiation pattern. Now just minimize this. Okay, so now you need to open Microsoft Excel. Okay, so just open Microsoft Excel. Alright, now create a new workbook. Now you need to open that particular folder here. So go to file, then open. Now go to browse. You need to pick up that saved file, ASCII file. So I save it in pictures, and you select the file type as all files, then it will show you the exact pen e-plane RP radiation pattern. Just open it. Okay, so it will ask you like a window will be coming, so here you need to choose the correct option. So click it as fixed width. Okay, then press next and next, and here the option should be general, and finish it. Okay, now you can see that two values will be there. So actually the first column is your frequency, and this column is the corresponding value. And now generally the radiation pattern what you see in the CST, it will look like it is the angle will be from 0 to 180 in the clockwise direction, and from 0 to 180 in the anti-clockwise direction. So totally for a circle the total angle will be 360. So here you need to adjust the values in this particular Excel. Okay, so you need to adjust the value. So instead of 90, and the first value is 90, and if you see the last value it is 450. So this particular column you need to change, and you need to make it as 0 to 1 360. So 0 1 2 3, then you can drag like that. Okay, so the value becomes 0 to the final value is show you final value is 360. Okay, so you need to adjust this value first. Okay, and after that we go for normalization purpose. The second column, that far field value, you need to normalize it. So here I'm going to normalize it. So I go to the third column, I'm putting the equation as f equal to, in order to normalize it, equal to, and this particular initial value, that is b3. Alright, so b3 minus, and max of, the equation is max of b is to b. Okay, so max of b is to b, and bracket close, and press enter. So you will be getting one value. So the equation is nothing but, so you are going to so the first value is p3, you are going to minus, subtract the maximum value of this particular p column. So that's what it is doing, and it will do for all the rows. So I'm actually extending this, so it will automatically find out the normalized value for that particular far fields. And you can scroll down, you can see that one particular column will carries the value 0. So let me see whether which column hold the value 0. So you can see here this one particular column carries the value 0. Okay, and this is the highest value in the far field. Now this value is actually minus, subtracted from the entire values of the far field. Okay, so this is a normalized value. So the third column value is the normalized value. So we will be using this particular frequency value, angle value, as well as this normalized value to plot the radiation pattern. Okay, now in order to plot this particular radiation pattern, I'm using a tool called originpro. Okay, so originpro. So I'm opening originpro. Yeah. So once the originpro software is open, you need to click on the first option, like a blank workbook. Okay, so now I'm going to copy that particular values, the 0 to 360 one value. So I'm just copy this to in the originpro. I copy this value, and now I'm going to copy the normalized value. Okay, so normalized value, third column is the normalized value. Just copy that too, and paste it into the second column of originpro. Okay, now I'm going to choose the two columns, AX as well as BX, both column BY. Now I'm going to choose, you can see one particular graph is available in the bottom part around here, polar theta. So just click on that arrow button. So here you can see polar theta X or Y. So choose that particular graph model. And now you can see that how the graph look like, and you can see one more thing that it is not properly oriented because 0 is in the right side, so you need to adjust that. Before that you need to adjust this particular value in the left side. So double click on the value, then click on show. Now see, you can see here it is 0. Then I need to make this particular, if you look at the CST, the 0 is in the top position. Okay, so I need to adjust that. So make it as counterclockwise. Okay, and choose this particular value as 90. Then see that, okay, now you can see that it is 0, 30, and likewise 360 degree is created. And after that scale value, and yeah, radial, click on the radial. Okay, so in scale click on radial, because radial axis is nothing but left side as axis, and if you need to adjust the values around this particular circle, you can go for angular. Okay, so click on radial. I need to adjust that to 0 this value. So it's 0 to minus 30 and 0 to minus 3. You just need to make it this. Okay, and yeah, so the view is correct. So you can see here 0 to minus 30 and 0 to minus 30. So this will be the axis of the curve. Okay, so this is the graph, and if you want to edit like here, keep playing, you can edit it here. So on that, on view, and you can type like keep playing. Okay, okay. And if you need to adjust this particular graph, you can increase the thickness to 2, and if you can able to choose different colors, right, you can plot it in red, or yeah, it's me plotting in red color, so that is also fine. So even better, you don't know this here. So this is the option, and so it's look like a clean radiation pattern diagram. So, and you can able to export this. You can go to file, you can export this particular graph, open dialog box, and you'll get a window like this. Then you can define the ratio like 3000. You can give different values, pixel values you can give it. Okay, so width value you can give as well as height value also. Okay, so that is possible. And after that, okay, so file is I need to properly choose the extension file, like you choose as clarity is super. So if it is IEEE, you will be pasted like in half of this particular earphone, and if it is any other channel, if you want a bigger diagram, we can able to increase. So this is how you can able to create E-plane as well as H-plane radiation pattern, and this is the way you can able to plot it for different kind of channel configuration. Hope you enjoy the video, and I hope you keep on supporting me. So kindly subscribe my channel so that I can able to do more videos for the benefit of you guys. Thank you.